Hello and welcome to this video tutorial where I explain how to get quickly started with new soil sensor from BigClown. So this tutorial will measure the soil moisture in your garden or in your flower pot where you grow your plants, and you can not only measure the moisture level by this capacitive sensor, but also temperature with the temperature sensor which is placed here. All the data will be sent wirelessly from this mobile IP64, I think, unit to the USB dongle and to the Raspberry Pi, which will create a simple dashboard where you will see actual values. And also I will show how to quick install Grafana, which is a very nice visualization tool to draw graphs and new see the trends. The Grafana is looking something like this. Here I'm measuring something different, the temperature and humidity from my climate module, which is outside. And today I will show you how to create this project and install everything on the Raspberry Pi. So let's get started. So the block concept is something like this. You have a Raspberry Pi, which is here. In the Raspberry Pi will be running BigClown gateway, and it will be connected to this dongle, which is the main point, the gateway to the BigClown network. But everything inside here is already prepared for you, because you can download the special BigClown Raspbian, which has all the services already installed. But you can also install them yourself on any computer which is able to run Python script. Okay, and on the other side we have this kit with this is the soil moisture kit with a battery module, sensor module, which has this connector, and here's connected the one wire moisture sensor, and the core module. Here's the core module 2, which has FTDI chip and only a single button, and to flash this you flash it like the dongle, USB dongle. You don't have to press any other buttons. This is the older core module, which is uploaded by DFU, so you have to press two buttons and use the //DFU in the command line. But already is in the everything is in documentation. All right, so first things first, we have all the modules prepared. You will need the Raspberry Pi with the BigClown Raspbian, so you can install the Raspbian by these instructions. If you are using Windows, Linux or Ubuntu, it's a good idea to use the Etcher. So first thing, you need to download the Raspbian, which is on our GitHub in the latest version. And then you can download Etcher, which is a very comfortable and easy to flash tool to prepare your SD card. I have the Etcher already running. And so you select the downloaded zip file. You don't need to unzip this file. You can flash it. The Etcher will unzip it itself. Then you select the SD card and flash it. The flash takes 2 minutes. Then the verification takes about 1 to 2 minutes. So I've already prepared the SD card before, so we can quickly move forward. So this was the Etcher, and this Raspberry Pi installation is done. If you would like to install it on the empty Raspbian, you can follow these instructions, and here are the commands to install the rest of the services you would need. So back to the tutorial. So first what we need to do is connect the Raspberry Pi and boot it up. So this will go So you would need the Ethernet, your local network, and power cable. Okay, it's booting. All right, so we will install the Grafana and on the Raspberry Pi, but first we need to log in to the Raspberry Pi. So we will follow this link, and this link tells you how to find your IP address, or you can use the MDNS address, which is hub.local, and this is the port 1880 which is running the Node-RED. So I'm already connected to this device. In case you don't know the IP address, then you can follow these instructions. I always prefer this one with the Thing utility. With the Thing utility on your phone, so you can simply run this utility. Click on the refresh button, and you will see I have a lot of Raspberry Pis on my network, but here is the hub which I would like to connect. So it has IP address 192.168.1.100. So it's also possible to write IP address like this. And don't forget the 1880 for the Node-RED. All right. So I've successfully connected to the Raspberry Pi. Now I will connect the USB dongle to it. And if you switch to the debug tab, then you will see MQTT messages from the USB dongle already. And you can see the firmware version which is running and what firmware is running on the dongle. This is the nodes which are paired, and there are no nodes paired, so we will do pairing a little bit later. But first thing, we need to make sure we use the latest firmware. So now we need to connect to the SSH. So we will follow the firmware upload, and you will need to connect to the Raspberry Pi. So this was already explained in Raspberry Pi login. If you use Windows, you can use the PuTTY program. And if you use Linux or macOS, you just use SSH command. So don't be scared with my Ubuntu in here. You can do everything the same way in Windows too. So I will create a new window, which is here. Oh, clear. And then I SSH to username pi and hub.local. Alright, I was connected on a different IP, so this won't show to you. Alright, and I answer yes. And the password is the default Raspberry, which is the same like with the usual Raspbian. Here you can see the welcome screen, which tells you important web addresses, forum, shop, and documentation. You can also see the IP address of the Node-RED. So here you can see the actual IP address, And here are the basic commands because we have some services running on the Raspberry Pi, and we are using the PM2 process manager software. And so this is information how to stop the gateway. The gateway is a simple Python script, BCG, which is converting the JSON messages from the dongle to the MQTT messages for Mosquito broker running on the Raspberry Pi. BigClown firmware tool will be using this to flash new firmware, and then there is a BigClown hub control tool, which is useful to start and stop pairing of the dongles. We will use more user-friendly flows in the Node-RED to start and stop pairing. So first, let's update the firmware. So connecting firmware upload. Okay, so I can use this command, but actually the first thing I will do is update the firmwares I already have on GitHub. This tool will download the list of all pre-compiled and prepared firmwares for the modules and kits. So you can flash the firmware, you don't need to compile anything or write any code. It will work automatically. Once this is done, we will take a look where's the soil moisture, soil sensor kit is, wireless, flat, wireless soil sensor. If you would like to search in this this list, you can always write bcf search and write soil, and you will see the firmwares you would like. So now I would like to flash the firmware to the connected USB dongle. So I will write bcf flash. Then I need to write the device, which is dev tty USB 0. I press the tab and it automatically completed. There is right now only one USB converter, and now I need this firmware. No, sorry. This is a dongle, so I would need USB dongle firmware. This one. Alright, and the latest means that it's downloading the last released firmware. So I will press this, and I did this on purpose because if you use PM2 list, which is the process manager, you can see that BCG is already using the serial communication line for the USB dongle. So we need to first stop this, and here is the hint: stop this command. Okay, so we have stopped the service and we can flash dongle once again. Okay, so now it's uploading. I will switch here so we can see the MQTT message when the module is flashed. Right, the verification step, and now I can start the BigClown gateway again, and you can see that it outputs its version, and again there are no paired nodes yet. So now I will flash the module, the soil moisture kit. I will disconnect this so it will be easier, because if we connect two modules, then one will have USB 0, the second one USB 1. So right now it's better to have only one connected. Oh, maybe not, maybe not, because this has already USB 0. So the other one will be USB 1. Otherwise, I will have to again turn off the gateway. So I will flash it with the connected dongle. So now connect the micro USB cable between the Raspberry Pi and the core module 2. And let's go back to the console. So I said that we will need soil moisture sensor kit. So bcf flash device dev tty USB, and if I press tab twice, then I can see that, I can see that there are two devices, USB 0 and USB 1. So 0 is dongle, 1 is the soil moisture kit. So now I will flash to the USB 1, and here's the firmware I would like to flash. And again, here's the version I would like to flash, but you can do latest and it will download the latest version, not this specific one. So it seems that everything is ready, and I'm using and flashing the module. Once the flashing is done, then the LED will turn on for a while. Alright, so we have flashed this, and now we need to pair these modules together. As I said, we can use the BCH BCH help. So we can start pairing, BCH pairing start, and this will enable pairing, and the LED on the dongle will start to blink, and it is. And the same way I can do this from the Node-RED with these buttons. So this is pairing turned off and on. And so now I will turn the pairing mode on, and all I need to do is restart or put batteries to the soil moisture kit. Oh, I need to disconnect the USB because it was powered by USB. But now you should see the pairing process in here. Alright. So it's paired, it's a wireless soil sensor, and you also can see that it's setting new alias to this kit. So it has quite nice name in the MQTT topics, kit wireless soil sensor. And you can see already then the moisture is going. This is the moisture in %, and this is the voltage, battery voltage. And we also have temperature from the sensor here. So now, just out of curiosity, let's start. Let's create first a simple dashboard with this setup. So I will create new flow, and in the flow I use gauges, and one gauge will be for temperature. First I need to create a group and the tab, so home tab, then a default group, and now this will be temperature from 0 to, let's say, 40. This will be the moisture in %, and this will be the batteries in volts from 0 to 6 volts. Let's say from 0 to, let's say, 8. And I forget the moisture is from 0 to 100%. Okay, so we have, if I press deploy and I will open the dashboard in here, it will show me the free graphs, free gauges, and I need to wire them so they will show the right value. So I will prepare MQTT input blocks here. So the first will be for temperature, so I will take this value and copy it and paste. Make sure there is no space in the front of this topic, because otherwise it wouldn't work. So this is for the temperature. Now the moisture is here. So paste. And the rest is the battery, which is here, battery voltage. And now just a simple connection will be enough. All right, it's already working. If I reset the module, then it will immediately also send the battery voltage. One thing I have forget, which you don't have to, is turn off the pairing mode, because this is not good. So I will switch to first flow and I will turn off the pairing mode, so it will stop blinking immediately. Okay, I have my dash. Now let's move, sorry again. Now let's move to the Grafana. I'm sure that we have done the radio pairing already, communication test, enclosures, and now let's move to the integration with Grafana. So the first step is to install the Grafana and InfluxDB, which is explained here. So let's move to this page. And all right. So again, we need to find our console. Make sure that you are connected to the Raspberry Pi. And now we will follow these steps. So first we install the dependency packages, because Influx is in the different repository. Then we need to add this repository to list of repositories. And this is a Raspbian, so we will copy this command. All right, and now just updating the repository and installing the Influx. So this done? Not yet. Okay, the Raspberry Pi is a little bit slower. So this is the Raspberry Pi 3, but the image would possibly work on Raspberry Pi 2. And if you would like to use another Raspberry Pi, then you have to follow the manual steps to install the BigClown gateway and BigClown firmware. BCG and BCF is already in the pip packages, so you just write pip install BCG, pip install BCF, and you can use them pretty much everywhere. Okay, let's start the Influx. Now let's move to the Grafana. And now this command will download the latest version. And after downloading, you need to install the dep package. So the Grafana will look something like this. You can simply by a mouse edit a lot of options, change colors, change SQL or the not SQL but the queries. All right, it's downloaded. So now let's install the no. Let's install Grafana. The Grafana is it's not some PHP site, PHP page. This is executable which will be running in a background, and it will also host this web page for you. And this website is connecting to the InfluxDB over the browser to the HTTP endpoint of InfluxDB. So it's communicating directly with the database. It's not going through Grafana. Okay, so it's already installed. Some final steps. And let's start the Grafana. Fine, let's test the Grafana right now. So Grafana is running on the port 3000, so hub.local 3000, and it was success. The password and admin is the same, but password and user is the same, admin. Okay, and we have empty Grafana here, which will need some setup, small setup. All right, so we installed, and now we need to another thing, which is a small script between the MQTT and the InfluxDB database, and this is done by MQTT to Influx Python script. And this Python script is using also the PM2 process manager, so it will run as the same way like the BigClown gateway is running or Node-RED is running. We will take a look at that in PM2 list command. Okay, so we install this script, then the script needs configuration. So we create the folder for this configuration. Which is weird. Okay, it exists. And we copy the file. Not copy, but open. This is the nano text editor. You can simply edit files here. I will show how to save and exit from this editor because sometimes it's a little bit tricky. So I will copy this configuration, insert it. And what this config does is that it's, as I said, it's connecting the Influx and the MQTT. So here is the MQTT broker, which is running on the Raspberry Pi. Here's the address of the InfluxDB, which is also running on the Raspberry Pi. So localhost address is here. And then you define the points you would like to draw. Here the measurement means that every block like this means that the data is stored in some table, let's say. InfluxDB calls the table's measurements, so this will be the table temperature, table relative humidity. Then you need to set the MQTT topic which is copying the values to this table. So we use node, then we use this wildcard. So from every node the values are going here. Then only the temperature from the sensor is written in this table. And the value is the payload of the MQTT message on this topic. And you can use tags. Tagging is something which you can use later to filter the values. So we will tag the ID, which is the first index of topic. So the topic is separated by these slashes. So this is topic 0. this is the topic 1, and that's why here's the topic 1. So the address of the module is actually the ID in the table, in that measurement. And every module can have a few more sensors, not only one, but many of them. So we also have channels. So the topic, the third item of the array. So this is 0, first, second, third. So the third item in this array is channel, because the temperature can be sensed, for example, from this sensor and also from the digital temperature sensor, which is located on the core module. And for every kind of sensor, we have this measurement. So I will press Ctrl O and save this. As you can see here, enter, and Ctrl X to exit the editor. Okay, so now we will need to test the configuration to check that it's okay. It's fine. And we will start the MQTT to InfluxDB service, because right now it's not running. There are only 2 or 3 services which were installed with the BigClown Raspbian. So we need to start this MQTT service, and it's already running. All right. We will also save the list of these services. So after the reboot, it will start again. Fine. So now we need to configure the Grafana. So I'll open the Grafana, and first thing we need to do is where are we? Here. The login, we already done that, and then we create a data source which will be node influx on this address. So you click on add the data source, name will be node, type will be influxdb, address will be this one, which is suggested. And don't forget the database, it will have the same name, node. Save and test, data source added. All right, we are done here. So let's create a new dashboard. And for the dashboard, you wouldn't like to click everything with the mouse. So we have prepared this JSON, which sets everything for you. So just select all, Control A, Control C to the clipboard. And now you create the dashboard, and you not paste, you dashboard somewhere option to create the dashboard from here. So you click on here and you click on import dashboard, and you paste the JSON you already copied. So you load it, select the node database we have created earlier, and do the import. And now we have prepared all the measurable values. As you can see, we already have the batteries from our source sensor, but we do not have the humidity, the moisture and the temperature. And that's because the MQTT messages are a little bit different, because it has different topic. So let's fix that. So we already done this. So we can close the Grafana and we will go back to the tutorial. And in the step 2, you can see we need to add the moisture and the temperature from the MQTT topics, which are created by the soil sensor. So once again, back to the command line, and we open the configuration file and go to the end, and we copy it. you need to put some spaces here and here, because it's a YML configuration file which needs to have right amount of spaces before the configuration items. So this could be okay. We can again, we can test the configuration if we did copying right. Okay, no problems. And because we changed the configuration, we need to restart the service. And it's restart and running. Okay. So now it could be possible that we see the first temperature in here. That's fine. And we don't see the moisture because we have relative humidity, but we don't have the moisture graph prepared here. So, but we can do it very easily. All right. So first, I can get rid of the unnecessary things, which is these tabs. So I will remove this panel row only. Yes. We don't use CO2. Yes. Luminance. Yes. Pressure away. Button. No buttons. Battery is working. All right. And now I create new panel. New row, which is here, and I move this row over here, and then we need to add the moisture. So I will simply duplicate this. I will take it and move to the row here. Sorry. So this will be moisture, and we click on the edit, and down here in metrics we need just to change the database, which is not the temperature but moisture. Okay, so I will select this, and you can see that it's already measuring. It's between 0 and 4 right now, because it's not the moisture sensor is just on the table, so it's changing values randomly, and that's all. Now I get rid of, for example, this. Remove CO2. And remove this, and we would also like to see actual moisture level, so I will click here, moisture, and in metrics I change relative humidity to moisture, and it's already here. Okay, battery. Don't forget to save this dashboard. You need always when you apply some changes, you need to click this 3.5 inch floppy, save, and now it's saved. So you can see all the measured data right now. So if you zoom in, then you see the temperature, the moisture. Sorry, yes, the temperature, the moisture, which is not moisture right now, but it is right now. Don't forget to save again, and the battery voltage of the module. Okay, so this is very simple introduction to Grafana, to the Raspberry Pi and BigClown Raspbian, which is pre-compiled, prepared. You just flash the SD card and it's working. Then you flash the modules, the core module and the dongle with the already prepared firmware. And after the pairing, the data will appear and you start measuring, and you can create the step-by-step your home automation and know when to water your plants, or when your flower pot is dry. You can also automate this and create in the Node-RED some flow which are based on the moisture level, and for example send the command to some other module which will turn on the water, so you can have automatic watering of your plants. So I hope you like this. Give this video a thumbs up, share this, and if you have any questions, just go to our website, our forum, and we will help you. Okay, bye.